Good morning. I will be continuing the homework review with Chapter 2, Question 2. And I have some news for you also. I have decided not to hold the class responsible for interpolation in Chapter 2. So you will, although I will show you how to do it, and I have uploaded in week 3 a file from the study guide to help you with interpolation, and I will demonstrate it in Chapter 2, Question 20 later on. I will not be holding you responsible for interpolation for this course. Okay, so let's go ahead and take a look at Chapter 2, Question 2. First off, the question says find each value for just grabbing my pen here, sorry. It says find each value requested for the distribution of scores in the following table. And the first that we want to get is n. And of course, we get the n by just simply adding up all the f's, or the frequencies. So 2 and 2 is 4, plus 4 is 8, plus 1 is 9. So the n is 9. Secondly, we want to do the sigma x, which is the sum of x, and as you can see, the answer is 31, and we get that simply by multiplying or squaring each of the values. So 5 times 2 is 10, 4 times 2 is 8, 3 times 4 is 12, 2 times 0 is 0, and 1 times 1 is 1. So again, let me give you the values. It's 10, 8, 3 times 4 is 12, and 2 times 0 is 0, 1 times 1 is 1. If you add those values up, you find a sum of 31. And the next one, we need to, well, that's my phone, just one moment. All right, we're back, and I think that we were doing this sum. So what we have to do is take a look and at the frequencies, and we have over here we have 5 times 5. We're squaring the first one, the first x, and we have 2 of them. So we square the x value, and how many times do we square it? We square it twice. So we have 5 times 5 and 5 times 5, and of course that's 25 and 25, so it's 50. And the next value is 4 times 4 twice, so 4 times 4, 4 times 4, and why am I doing it twice? Because the frequency is twice, and the value is 32, and the next one is 3 times 3, 4 times, and 3 times 3 is 9, 9 times 4 is 36, so 3 times 3 times 4 times is equals 36, and 2 times 0 is 0, and the next one is 1 times 1 is 1. So if you add those up, you get a total of 119, which is the answer to the next question C. Popping over to the next page, we are simply here going to make a list of it's question 4. We're going to make a list of intervals. So we for the following scores, the lowest value is x equals 13, and of course that's here, and I'm sorry, couldn't quite get that circle, 13, and we're placing the scores in a frequency distribution table, and first we're using an interval of 5, so we're going to start at the lowest one with 13 in it, so we go from 10, 11, 12, 13, and 14 is an interval of 5. And the next interval of 5 is 15, 16, 17, 18, and 19. And so let's just do the first one here. The first one is has 1 in it, and that is 13. And the second one, we're looking for values including 15 and 19 and everything between them. So if we pop over here and we check each score out individually, we are going to find that we have 116 and and 118. So there are 2 numbers in this. So the frequency is F, and it goes on. So that we'll have 4 values or 4 X scores between 20 and 24, 1 between 25 and 29, 5 between 30 and 34, etc. And with this table, we're simply increasing the interval to 10. Okay, so that is a relatively easy one, and we'll pop over to the next page. And it's asking under what circumstances should you use a grouped frequency distribution instead of a regular frequency distribution. And of course the answer is a grouped frequency distribution is used when the original scale of measurement consists of more categories than you can list simply in a regular table. So more than 15 categories is generally considered too many for a regular table. So just remember, if it's looking really complicated, you could break it up into intervals. And it's very handy to do with ages, by the way. If you're doing an age group from infancy to senescence, you may want to start doing a 5 or 10 year frequency interval. Okay, popping over to the next one is question 10. A survey given to a sample of 200 college students contained questions about the following variables. For each variable, identify the kind of graph that should be used to display the distribution of scores. A histogram, a polygon, or a bar graph. Okay, A is the number of pizzas consumed during the previous week. And of course, the number of pizzas is a continuous number. It's a ratio scale, and you want to use a histogram or a polygon. B is the number of t-shirts, size of t-shirts worn. And don't forget now, size is an ordered array, so that is an ordinal scale. And you want to use a bar graph for ordinal scales. Same with C. The gender is a nominal, and you also want to use a bar graph. Whereas D is a grade point average. That is a ratio scale, like there's a continuous number. So you want to use a histogram or a polygram, just like you did in A. And a college class is just an ordinal scale. You're a freshman, a sophomore, a junior, or a senior, or like you guys, grad students. So you want to use a bar graph. And popping over to the next question, this is simply a exercise in putting things in order. Okay, so an instructor at the State College recorded the academic major for each student in his psychology class and obtained the following results. A, conduct a frequency distribution, or construct a frequency distribution table for these data. All right, and we had, it's a distribution table. We had, if you look here, these are the X's and their names, okay, and they're in alphabetical order, right here. And so we find that we had 2 art students, we had 1 bio student, 1 English student, 3 health students, etc., etc. There were a lot of psych students in the psych class, 9. And that's just it. What is it? It's these are all names. Okay, these are all names. They're not continuous values or anything like that. So the kind of graph we're going to use for names is a bar graph. Okay, we're just going to pop this one down. I'm going to end this one and pop into the next one because we're going to actually get into some numbers, and I want to take a little time to actually go over those. And I have a 15-minute limit on YouTube, so I'm just going to pop to the next page, and then we'll go ahead and talk about these a little bit more.